Hello everyone, welcome back to my channel. So in this video I'll be explaining you about another four important properties of aggregates, which is moisture content, bulking, soundness and cleanliness. So you can even watch my earlier videos where I've discussed about various properties of aggregates like classification based on source, texture, size, shape, and then about alkali aggregate reaction. And now we are dealing with four another important properties. And my next video will be on thermal properties and sieve analysis. So by this, the complete topics relevant to aggregates would be completed. So you can watch in the concrete technology playlist for sure. So today we'll learn about these four properties which are very much important when aggregates are used in concrete. So first one is moisture content. Some of the aggregates are porous in nature and they are very much absorptive in nature. So they may absorb water because of this absorption, the water cement ratio will get affected and hence the durability of the concrete will get affected. So the absorption in the aggregate should be calculated or can be calculated by the difference in weight when it is put under water for 24 hours, what we call as the water absorption test. Due to the sealing of pores of aggregates in the concrete, the absorption decreases, so the extra water should be added accordingly rather than 24 hours absorption rate. Now another important factor is that if we add moist aggregate into concrete, it will add up water to the concrete, and if we add dry aggregate, then it will absorb water from the concrete. Hence corrective measures should be taken for both, otherwise the water cement ratio will get affected. Often in concrete, generally dry coarse aggregate and moist fine aggregate is used. The moisture content in the fine aggregate does not become necessary, but when it bulks, then it becomes necessary. So what you can see on the screen is four types of aggregates which are classified based on the moisture content. The first one is oven dry. So all the moisture is removed by heating the aggregates in oven at around 105 degrees centigrade to constant weight. All pores connected to the surface are emptied and the aggregate is fully absorbent. Second one, you have air dry sample. So all moisture is removed from the surface, but pores connected to the surface are partially filled with water. The aggregate is somewhat absorbent. Next we have saturated surface dry aggregates. All pores connected to the surface are filled with water, but the surface is dry. The aggregate is neither absorbent nor does it contribute water to the concrete mixture. Last we have wet or damp aggregates. All pores connected to the surface are filled with water and there is excess moisture on the surface also. The aggregate contributes water to the concrete mixture. Next we have bulking. So what is bulking? Bulking of fine aggregate or sand is the phenomenon of increase in sand volume due to the increase in moisture content. One has to be very important or very careful that you need to perform the bulking of fine aggregate experiment before it is used in construction. The moisture content in the sand makes thin films around the sand particles due to surface tension. Hence, each particle exerts pressure. Hence, they move away from each other, causing increase in volume. The bulking of the aggregates is dependent upon two factors. First one is fineness of the aggregates and second one is percentage of moisture content. So from this graph you can observe that the bulking of the sand increases with increase in moisture content. This will happen only up to a particular limit, beyond which any moisture addition will decrease the volume. And always remember, a fully saturated fine aggregate does not show any bulking. The rate of bulking is inversely proportional to the size of the aggregates, and hence fine aggregates bulk more when compared to coarse aggregates. What is the significance of performing the bulking test? Unrealistic volume is shown by fine aggregate due to bulking. When concrete proportioning is to be performed, the sand bulking issue is always a concern. If the effect of bulking is not studied properly, the concrete design will have an insufficient amount of sand, which is resulting in a very harsh mix. Bulking of sand will affect the yield of concrete for a given cement content. Hence, one has to be careful with the bulking. Next, we have soundness. What do you mean by soundness? Soundness refers to the ability of the aggregate to resist excessive changes in volume under change in any physical condition. The physical conditions could be like freezing and thawing, variation in temperature, alternative wetting and drying in salt water conditions also. So aggregates which are generally porous, weak and which contain undesirable matter will undergo easy volume changes when they are subjected to the physical conditions as mentioned. Aggregates which undergo more than specified amount of volume change are said to be unsound in nature. If the concrete is liable to be exposed to the action of frost, the coarse and fine aggregate which are to be used in this concrete should be subjected to soundness test. So how is the soundness test performed? Soundness test is performed by submerging the aggregate sample in sodium sulfate or magnesium sulfate solution. This process causes salt crystals to form in the aggregate's water permeable pores. The formation of these crystals creates internal forces that apply pressure on aggregate pores and tend to break the aggregate. What you can see in the first figure. After a specified number of submerging and drying repetitions, the aggregate is sieved to determine the percentage loss of the material. The formation of salt crystals is supposed to minimize the formation of ice crystals in the field and could therefore be used as a surrogate to predict an aggregate's freeze and thaw performance. So you can see in the diagram aggregate before and after performing the soundness test. Next we have cleanliness. The concrete aggregate should always be free from impurities and deleterious substances which are likely to interfere with the process of hydration, prevention of effective bond between the aggregates and the concrete matrix. The impurities sometimes reduce the durability of the aggregate. Fine aggregate which is containing silt, clay and sometimes organic impurities because it is dredged from the riverbed, and even manufactured sand also contains stone dust. We have some unused coarse aggregate which always contain moss and mud beneath them, and the salt which is there in the aggregate also may affect the similar way how a marine water will affect the concrete. The quantity of clay, silt and dust are also to be considered, and they are determined by sedimentation method. So aggregates which are from sources like from any other source, like they may contain iron pyrites, clay nodules, soft shale particles and other impurities which are likely to be swelled when they are wetted. These particles also get worn out when concrete is subjected to abrasion, and thereby they cause pitting action in concrete. Such unsound particles cause damage to the concrete, particularly when they are subjected to alternative freezing and thawing. So a limitation to all the quantity of such impurities is shown in the table 3.5, you can see, which is from IS 383/1970. So it tells what are the deleterious substances which could be in aggregate and what is the maximum percentage they can be. So I hope you all understood the video. Thanks for watching.